We welcome you all, and it's my pleasure now to present to you Professor Keen Martins, who will introduce the panel. Keen?
Yeah, so welcome to this panel on the future of the aircraft industry. And as a moderator, we have Dr. Benzakien, Mike Benzakien. He is the Wright Brothers Institute professor and director of the Propulsion and Power Center at Ohio State University. He assumed this position in July 2010 after completing 5-year tenure as the chair of Aerospace Engineering Department at OSU. He came to OSU in early 2005 after retiring from General Electric, where he led the research effort in computational aerodynamics, aeroacoustics, aeromechanics, and combustion. He's a member of the National Academy of Engineering, a fellow of the AERO, and a fellow of the Royal Aeronautical Society, and he received the Gold Medal of Honor from the Royal Aeronautical Society in 2001. Dr. Benzakien is the recipient of the GE Chairman Leadership Award for Technology and the 2007 AIAA Reed Aeronautics Award. He has served on many National Academy, industry, and government advising panels over the last 10 years and received an honorary doctorate from the University of Poitiers in France in 2006. And now Dr. Benzakien will introduce the panel.
Thank you very much. Good morning, ladies and gentlemen. I really want to start by thanking Dan Inman and the whole University of Michigan team for really a wonderful hospitality. This is a terrific forum, and it's a great place for a celebration. We're going to start this morning with a discussion of the aircraft industry. Let's face it, this is an exciting project. If we go back a little over 100 years ago, the Wright brothers took off along the shores of North Carolina. They flew for a number of seconds and went a few hundred feet. Their flight was powered by two 25-horsepower engines. It was indeed a tremendous achievement. On first day of this week, I boarded in Beijing a Boeing 777-200 aircraft. The plane is powered by two GE90 115,000 pounds of thrust engines. We flew for 12 hours, over 10,000 miles, and landed in Detroit yesterday afternoon. What is amazing is this is being done every day by hundreds of airplanes. We're doing this safely, efficiently, reliably, with a minimum pollution and at a reasonable cost. This is what the airline industry has accomplished. It's really terrific. It's really obviously beyond the dreams of the Wright brothers. They might have never thought anything like that could happen. Closer to home, I remember 25 years ago, sitting in Seattle, when we were discussing the feasibility of having twin airplanes cross the Atlantic, let alone the Pacific. This is when ETOPS was invented and executed. Look at where we are today. But we're not done. Great products are coming from Boeing 777Xs, A350s, new A320s, 737, Comac 919s, but will be followed by more efficient, more maintainable engines, and lower pollution and lower noise. This is an industry which will offer more challenges and opportunities to our students. There are great careers to design, qualify, and fly new great products. It is an exciting world. To talk about where we are today and where we're going, We have a terrific panel. We have Kerr from American Airlines, Karem from Karem Aircraft, and Tracy from the Boeing Company. I'm going to introduce each of one of these speakers in a minute. I propose that we have all these speakers go for their presentation, limit our comments to any clarification questions, and we'll then open the floor to discussions relative to the presentations and related subject of the panel. So, let me briefly introduce the speakers. Derek Kerr is the Chief Financial Officer for American Airlines Group and the principal subsidiary company, American Airlines. He oversees financial planning and analysis, corporate finance, and treasury function, purchasing, control, audit function. He served as Executive Vice President, Chief Financial Officer for U.S. Airways, a role he began in 2009, and prior to that, he was Senior Vice President and Chief Financial Officer. Joined American West in 1996 as a Senior Director of Planning and promoted to Senior Vice President. He has a Bachelor of Science in Aeronautical Engineering and a Master of Business Administration in Finance for the University of Michigan here in Ann Arbor. He served on the Board of Directors of the Fiesta Bowl and the Phoenix Zoo. Let me say a few words about Karem. He's currently the president and founder of Frontier, he has a Bachelor of Science of Aeronautical Engineering from the Technion University in Israel. Okay? He has an outstanding background in industry. In 76 to 79, he was in the Israeli Air Force as an engineering officer and initiated and led the quick reaction development of deployment of 12 systems related to tactical aircraft. From 79 to 81, he was at Israel Aircraft Industries. He led the aircraft design group for the Fear Fighter through release of production drawings. In parallel, he established the Advanced Design Group in a miniature 25-people skunk works and initiated lead design on a number of different vehicles. 81 to 84, he was the president and founder of Matos, an Israeli company, initiated development of 8 UAVs and 3 manned aircraft. 94 to 91, in charge of development sizes, he led the development of several UAVs. From 62 to 90, he was the president and founder of Leading System. A primary focus was the development and pilot production of high-performance UAVs, advanced subsystems. I said it goes on and on. 91 to 94, he was the chief engineer of General Atomics Aeronautical Systems and later consultant to NAT 750, the Prowler and the Predator. President in 91 to today, he's the president founder of Frontier System, developed the Optimum Speed Rotor, the Maverick A and Hummingbird UAV system. The Shadow UAV designed the UAV system, developed and delivered 2 pre-production technical reconnaissance pods, developed advanced UAV avionics, data links, and mechanical systems. Up to today, he's the president and founder of Frontier Aircraft, which is now Karem Aircraft Company. The last gentleman on our terrific panel is Tracy. Dr. Tracy is Boeing Chief Technologies Officer and Senior Vice President of Engineering, Operation, and Technology. In his position, he oversees the development and implementation of Boeing technology investment strategy and provides strategic direction to function, business, organization, and initiatives involving more than 100,000 employees. These include Boeing's engineering operation and supply and technology, test and evaluation, intellectual property management, environment, health, safety organization, and Boeing development program excellence and information services and information management initiatives. Dr. Tracy earned his PhD in engineering from the University of California at Irvine and a master's and bachelor's in physics from California State University, Los Angeles and California State University. So let me start by introducing now Derek
Thanks, Mike.
Kerr.
Thank you. Appreciate it.
What I want to do is just kind of go through the evolution of the airline industry and kind of show you where we've been over time and how we got to where we got. So the one thing I want to start with is just making sure that everybody understands that the airline industry is a network business. That's a key to everything that happens in the airline industry. And the fragmentation of the industry was there early on, and now we've tried to reduce that fragmentation. But the key thing is it's a network business. The bigger the network is, the more you have the ability to bring in customers, and the customer has the ability to fly anywhere they want to fly. There was a lot of fragmentation in the industry. As the mergers happened over time, I'll show you how that changed and how that changed the networks. But the competition from a major network carrier, how do you compete with the low-cost carriers, is you have the ability to get customers where they want to go, fly where they want to fly across all of the country, and make sure that you capture those business customers that really want to be your frequent flyers and fly you all the time. So it's necessary as you go through this to understand that the network is the key thing as we go forward. So from deregulation on, you can see that there was a bad calculation going on in this industry. As costs continued to rise, so we were deregulated until 1983, costs continued to rise as we added the cost to, mostly on the labor side of things, as the revenues declined. And the revenues declined because there was more competition, more carriers coming into the environment over time. So with that equation, it just doesn't work for an industry as you try to move through the industry. So what you saw is you saw an industry that at good times made some money and did okay, but at bad times really, really lost a lot of money. And if you add that up over time, it's negative. You know, the entire industry has lost money since 1983 and continued to lose money. And so how do you go fix this industry and make sure that, we are like the other carriers, other corporations, where in the bad times, we're going to be cyclical. There's no doubt you're going to be cyclical, but how do you make it so that in the bad times you actually still make money instead of losing billions and billions of dollars in the bad times? So this is kind of an eye chart. There's a lot up there, but what it's kind of telling is throughout the time period from 1983 going through to 2003, there was a lot of change between carriers 4 through 10. Not a lot of change at the top 3. It was always United, American, and Delta, and they moved in and out. Sometimes United on top, sometimes American on top, but they moved a lot. But what you can see from 1983 is how fragmented it was. The number 10 carrier had 3% of the industry, and there was another bunch of carriers underneath of that had 17% of the industry. So the top carriers only had about 15% of the industry, and as you moved across, it kind of stayed about the same. But between 4 and 10, the names changed a lot. So what happened is there were mergers within, smaller mergers that went on. Some carriers underneath went away. You see the Pan Am and the TWAs go away in the 83s and 88s because they didn't make money. They lost money, went bankrupt, and went out of existence. Some mergers happened, so then you see Southwest kind of come into play in 1998, which was significant to this industry. Southwest is the premium pricer in the industry today and was the low-cost carrier at that point in time. So you see a lot of changes, not a lot of changes in the big 3, but if you look at where the big 3 percentage went from 36% to 50%, so kind of a shift up into that area. So what happened? Then we had our issues in 2001, which the dot-com bubble came, and then the 9/11, which was a significant shock to the industry, and then the recession in 2009. So you had 2 huge plummets of revenue. There's 2 things that are hard to control in this industry. One is the fuel price, and one is revenue. And how do you react to these two revenue bumps, which happened in 2001, where you had a few airlines that went out of business and others had to scramble to stay alive, and then the recession in 2009, which caused a lot of things to happen. Then you have the fuel price spike, which you can see we ran at about $20 a barrel all the way to about 2003, and then had a spike up to 40, and we thought, oh no, here we go, it's going to 40. And then by the time you hit 2008, you end up at $140 a barrel. And so how do you survive in an environment where it's at $140 a barrel and your revenues are plummeting with a recession in 2009? How do we make it through that? Well, a lot of carriers didn't make it through that, but we had a lot of things happen. I'll just whip through these for time purposes, but industry had to go through restructuring. We had to figure out how can we survive. A lot of carriers into bankruptcy. There was a merger with U.S. Airways and United a long time ago. That had to be abandoned. They couldn't go forward because they didn't have the cash to move forward. There were bailouts coming out of 2001 with the ATSB. I was at America West at that time as a low-cost carrier. America West and U.S. Airways were two of the beneficiaries of the ATSB program that came out right after 9/11. And raised enough money to keep around. Old U.S. Airways went into bankruptcy twice. United, Delta, Northwest went into bankruptcy. You can see the only one that didn't go into bankruptcy was American Airlines. They did not go into bankruptcy, restructured. Everybody else went into bankruptcy really to go in there, restructure the debt, and lower the labor costs. Because the biggest difference between the low-cost carriers and the major carriers was labor costs. The industry wages had gone up to be uncompetitive, and so what had to happen is the wages had to come down and the costs had to come down to be in line with the revenue generating capabilities of the industry. So you saw a huge restructuring going on. The next step of that, well, the other one is shareholders had to pay. You know, a lot of people in bankruptcy, shareholders lost. So there's a lot of confidence, lost confidence with shareholders out there and buyers of the airline stocks that we have to regenerate at this point in time, and I think we're doing that finally. So what happened? The industry had to consolidate. How do you needed to take out capacity and you needed to consolidate the industry. So the first merger was back in 2005. I was at America West and we merged with U.S. Airways and brought them out of bankruptcy when they were in bankruptcy. Delta and Northwest, actually the U.S. Airways tried to merge with Delta. They were rebuffed, but it forced the Northwest merger to happen, so Delta and Northwest went together. Then again, U.S. Airways went after United. We were really close to getting that done, and then Continental came in and they said, all right, we need to merge because otherwise we'll be left out and we'll be one of the lower carriers. So United merged with Continental, and then Southwest merged with AirTran. So at that point, you ended up with a little bit of different environment. So now the big three were 68% of the industry. United and Delta became 26%, both about 25% of the industry. American lagging a little bit. U.S. Airways, we were lagging down a far bit, and Southwest was doing really well in a niche market of being just domestic carrier, really strong domestic carrier. But now you've consolidated the industry down from about 12 carriers that had 1% down to about 8 carriers that had 1%. So there's one left to do, and that's what I would talk a little bit about creating American Airlines and what we did and how we had to do that. It was a network problem. American Airlines had a network disadvantage versus United and Delta. United and Delta were basically taking off, had a network that was better than everybody. I'll show you what happened in that with, I think you can see this, but what happened in the network is back in 2006, before all the mergers, American Airlines had the best network in the industry. This is across the nation, just taking splits of it and by share size. So across the country, American on the West Coast was number 3, number 1 in the Central, and number 3 in the East Coast. Continental, was really strong on the West, but not strong on the East, and then Delta was strong on the East Coast. So it was kind of detente there. They all had a really good network, similar network. But once those mergers happened, you can see that Continental was 2, or United was 2 across the board. Delta had a huge, strong position in the Central and the West, or in the East, number 1, and then American was kind of left behind. They were 4, 4, and 5. And so they didn't have a network that could compete with Delta and United. And what happened there then, so you don't have this network, so what happens is you lose business traffic, you lose corporate share, you lose elite travelers, your revenue declines, So there's a lot of charts that show their corporate share dropped 20% because they did not have the ability to get everybody where they wanted them to go. A corporate customer would choose Delta or United over American because of the fact that they had the ability to get anywhere. They could get to Europe, they could get to Latin America, they could get to the Pacific, and so American had a network disadvantage. U.S. Airways was in the same boat, much smaller, with a network that was not as strong. Really strong out in the West, but not strong anywhere else. But we lived on a cost advantage. So the reason U.S. Airways was able to stay alive and have the margins that everybody else did was TRASM is revenue per ASM, so how much revenue we get per flying, and versus cost per ASM. So we lived in a different world where we had to keep our costs below the level of everybody else because we didn't have the revenue generating capabilities of the major carriers because our network wasn't as good. So we had a cost advantage really driven on the backs of our labor costs were lower than the major carriers, and it had to remain that way until we were able to merge. So what we did is we put the two airlines together, which is now the largest carrier in the world. It doesn't really matter that the largest carrier in the world. It really matters that we're three similar sized carriers and can compete from a network perspective. And when you take the network chart, 4, 4, and 5, and U.S. Airways 6, 5, and 3, we became number 3 on the West Coast, number 1 in the Central, and number 1 on the East Coast, which is the most lucrative business market out there. So a significant advantage as we're trying to compete with Delta and United. And you look at the network, best domestic network out there to compete with Delta and United. I think from a enhanced global network, from the Atlantic, we're all about the same size in the Atlantic. We all have the same share in the Atlantic. American is much stronger in Latin America, where United and Continental are stronger in the Pacific, and we have to grow the Pacific to get to be more competitive. But a really global network that now, when you talk to corporate customers, you can get them anywhere you want to get them, and so the network is very, very strong. And the other thing in the industry is, if you notice, there's 3 major global alliances that were not all the same. The One World Alliance, which had American and BA in it, were much smaller than the other 2 alliances, but as you change this, you end up with 3 alliances that are about the same. So it really equates everybody and equates the industry to you got 3 major carriers, 3 major alliances, and 3 major partners across the ocean. The other thing that happens when you do this is synergies. So this is the part where the Wall Street and those people, this is what they're looking for. You put the 2 together and you try to save costs, and the estimation for this merger is $1.4 billion. So you put the 2 airlines together, save $1.4 billion, and produce profits. So what has that done for the industry? So if you go to 2010 pre-margin, our pre-tax margin prior to the industry, we were all in about the 4% margin range. But the ability to put the big network together and the ability to now go from 12 carriers in a very fragmented industry to a much more consolidated industry with 3 carriers, and if you add Southwest into that, you have 4 carriers that have over 85-90% of the market share and are able now to be able to price and be profitable and get margins for this year, projected margins for this year in the 9 to 10% range, which is the highest pre-tax margin that any airlines have had in the history of the airline industry. So I just wanted to run through that a little bit with you and just show you where we've been and how we get there. It was a huge fragmented industry with a lot of carriers, a lot of low-cost carriers coming in. We had a lot of disruption during the last 10 years, 11 years. We've transformed from 12 carriers down to 6 carriers. The whole point here is to try to make the industry a profitable industry and a profitable industry in the good times and the bad times, and try to make it an investable industry so that people want to invest in the industry and not that we're out there, making a little bit of money in the good times and losing our shirt in the bad times. So I think we're there. I think we've gotten to a point where the industry is healthy. and we're going to move forward and make it more healthy as we move forward. And you have really 3 really good competitors, with Southwest being another great competitor, and we'll have an industry that is a lot more stronger and stable for everybody going forward. So, thank you.
I would like to talk about innovation, and I'd like to talk about words like disruptive. To me is positive if you can make it stick. And another word I like is mischief. So in innovation, mischief is good. So, and I would like to give you a historical perspective as how fast things moved in the past. So innovation is my topic here, and we are showing like 3 very innovative aircraft, or a big step forward. On the right is something that we are chasing that may or may not succeed. So I'm showing you 1939 North American. This is the best aircraft they had. It's a trainer. The Brits call it Harvard, and the Americans call it Texan. And that's the same North American 25 years later, Mach 3 from here to Moscow. And we didn't build it because the Russians built the MiG-25. This is Lockheed in 1933, famous Vega. If you wanted to go and break some records or go around the world, you have to buy one of these. And this is only 31 years later, SR-71 Mach 3, maybe 300 miles. You go around the world by refueling. This is Boeing, 1933, a very advanced aircraft that only the DC-3 of Boeing beat it. And the Model 247 was coming at the same time that we had the tri-motors as being the ones that controlled the market. Now, this is only 36 years later. 747 was a major step. This is not a twin-size 707. And it took Boeing convincing the customer at the time, Pan Am, to do something that big a step. We still have the 747 today. A lot of different things changed. 36 years. In helicopters, this is an amazing story. Sikorsky R4 was a fabric-covered 200-pound, 2-seat in production in 1942. And this is only 20 years later. The CH-47 and the CH-53 were not prototypes only. They went into Vietnam with hundreds of aircraft. So this is the pace of things, and you say that's because of wars. I'd say in these 30 to 40 years, we had 5 years of war, and the rest were all pushed by the commercial competitiveness. If we talk about factories, this is the famous North Hollywood, 1927, the Vega production. You can see C-clamps on the trailing edges, glue, and the templates of the girders. Now, that's only 17 years later. This country had 2-mile-long production lines because one was not good enough. The country built 100,000 fighters and 60,000 bombers, and a big number of transport and trainers in a matter of 4 years. Another perspective that is very troubling, and I want to really separate between the commercial industry, and I have 2 mainstream in here, both the customer and Boeing. The commercial industry is very competitive and efficient. We can talk about innovation later. And we have also the military. And the military, this is the famous Norm Augustine chart that says that tactical aircraft costs go exponentially up. Strange enough, the F-16 moved from the A version to the Block 50 and 52 D version in about 20 years, and the cost went down it probably was the same, but the 50 was infinitely better aircraft with a lot more. So if you can say in cost and money, the price went down, and we are not doing that. We are doing F-35, we are doing F-22. We did F-22. And the Chinese are stepping into the market of replacing 11,000 MiG-21s and 6,000 F-16s. If you say that's because of inflation, the red line is the commercial inflation. So you can see that the constant cost is going up. Another troubling thing in the military, but it's not in the commercial. You see that we could take an idea to the market in about 5 years. Now, I'm not talking here in wartime that the P-51 Mustang was flown in 4 months. It's really 117 days and went to market in 12 months. And because it came to market very late, this country built only 16,000 of them versus 35 of the Messerschmitt 109 and 25,000 of Spitfire. You can see that the time to market of military aircraft is going from 5 years to 25 and 30 years. And that's unsustainable. China is not doing the same. I'm somewhat concerned about it. Exciting is the fact that the commercial airliners, means Boeing, Airbus, Embraer, and struggling Bombardier, still going between 4 and 7 years. When they make a mistake, the 787 had a glitch, it went to 7 years, but not to 30 years. Amazing also that the time to market of ever more complex cars is going down. My background, I'll be very short on that. I came from tactical aircraft and some commercial aircraft in Israel. And I had 3 teams in Israel, 3 teams in this country. The team that went with fixed-wing UAVs, really taking an industry that was sitting on hands, basically $4 billion spent over 18 years with nothing to use, nothing useful, and $40 million in 4 years, in 5 years, I'm sorry, we created what we have now in fixed-wing UAVs. I tried to do the same thing in rotary wing. We had to create a new rotor, which is variable RPM rotor, and we were rudely interrupted. We sold the company to Boeing, and that disappeared. But we are chasing now something substantially more difficult, bigger mischief, if you want, which trying to do a 737 as safe, as efficient, as the same cost per seat mile, a tenth of a Mach number slower, but flying higher, because we didn't want to really fly at different speed at the same altitude. We'll see if that happens before I have to retire. I'm only 77 now. If we look at rotorcraft, we see something like an anomaly. We know about the anomaly of water. There's an anomaly of rotorcraft. In 20 years, the rotorcraft between 1940s and 1960 moved very, very, very rapidly and then went flat. And if you say, so how about the tilt rotor? I say, okay, It made a step and then went flat after that. So what we have is a technology that in '78 tilted the rotor and did a very good aircraft called the XV-15. It's available very much like I stepped into UAVs because people were not doing very well. People call me a genius. I have not met a genius in my life. But when you have people who are stationary for decades, you can step in and bring it to where it can be. So we're doing two programs, one with the Army and one with DARPA, that is trying to bring rotorcraft to where they could be instead of where they are. And you don't jump on the big companies. The big companies are responding to Wall Street. And if they can make profit with low risk, they will have to do that, or otherwise Wall Street will push them down. So one of the aircraft was a big transport that we did with the Army. It almost happened, but the Air Force decided they want to do stealth bombers instead. And that's taking 41 ton and going to substantial ranges with a range that is global without the heavy load. And by the way, that had to be 0.65 Mach number because it is also a tanker for heavy loaded F-16. This is the aircraft we are dreaming. And basically, because we are not going to be in the career fair next week, this is the first time I'm saying we are looking for very few very good people. Don't press too long, you get too.
It's a pleasure for me to be here. First, congratulations to the University of Michigan on achieving their 100-year birthday. You know, Boeing also is going to be 100 years old in 2016, and the two birthdays are sort of related because we probably have close to 1,000 Michigan engineering graduates on our team today. And so the fact that we're both reaching 100 is definitely linked. And some of those Boeing folks, I believe, are here with us today. Excuse me. My discussion this morning is going to focus on the commercial aircraft of the future and the state of it. And some of the constraints that I believe could keep us from achieving the vision of the future that we see, in particular, the constraint around the environment. As Derek pointed out, since 1980, we've had 4 recessions, 2 financial crises, 2 Gulf Wars, 1 oil shock, the SARS epidemic, 9/11, and a couple other smaller things. And in spite of all of those things, commercial air traffic in terms of revenue passenger kilometers has continued to grow at 5% a year. Anytime you have one of those events, there'll be a slight dip, but there'll be a response, back to the line, and there's this very steady growth of 5% a year. This is tied almost directly to the world's GDP growth. If the world's GDP grows at 3% a year, then we have seen over the last, several decades, fleet growth of a little over 3% a year, 3.5% a year, and that has turned into revenue passenger kilometer growth of 5% a year, driven mainly out of areas of China, Brazil, India, in the Middle East. At Boeing, we have something, and Airbus has a similar process called what we call the commercial market outlook that we've been doing for the last 30 years or so, and every year we predict what the growth in the fleet is going to be over the next 20 years. And that's what this is. So we've been doing this process for decades. We check its accuracy. It's our estimate based on all the data, very complex models, but it's also, there's very similar models based on data that Airbus looks at as well. And when we look at what the growth is going to be for the next 20 years, this is last year's, from 2013 to 2033, we see a couple of things. First, the fleet today is about 21,000 airplanes. But over the next 20 years, we're convinced that that's going to double to 42,000. These are commercial transport. I'm not talking about general aviation. 42,000 airplanes. That will require, over the next 20 years, 36,700 new large commercial transports worth over $5 trillion. It's an absolutely huge market, and it's growing dramatically. In that, of those 36,000 airplanes, 21,000 are, 60% are going to be for the growth in the flying public, and then another 15,000 is to be replacement, and 5,000 are the retained fleet. Now, that trend has been going on for a long time. If it continues 20 years after 2030 to 2050, then, and you just, extrapolate the growth of the fleet another 3%, by 2050, the fleet grows to 60,000 airplanes, and we go from having 70,000 departures a day in 2010 to something like 300,000 departures by 2050. This is staggering growth. This is a vision of what the industry could be, but there are constraints, there are obstacles, there are roadblocks that we have to figure out how to deal with to see this vision. And this is an important vision for the world's economy. I think commercial air transportation and the industries that support it create something like 5 to 8% of the world's GDP. So it's important for us to achieve this vision, not just for the sake of the industry, but because it's so tied into the world's GDP, interwoven. The constraints that we as an industry, the academic world, whatever part you're from, have to deal with are a few. The first is environmental concerns. What's the environmental impact of this industry, and how can you deal with that? The second is high oil prices, and the third is the airspace capacity. Can the air traffic management system handle this type of traffic? Let's start with the environment. This chart shows emissions by various industrial sectors and how they grow from 2000 up to 2030. And it happens to be measured in millions of tons of CO2 per equivalent year. So you can see that, in 2000 and probably up to today, the commercial aviation industry is responsible for only 2% of the man-made CO2 in the world. But because of the growth I'm talking about, that could easily grow up to 3% by 2030. This is an issue that we have to think very seriously about counteracting. This is in the public's mind. I know it was probably 5 or 6 years ago, it might have been longer, that Prince Charles in England canceled one of his vacations. It was a ski vacation, and the reason he gave for canceling it was because he said he didn't want to have an impact on the environment by flying on a plane. And so this is in the public's mind. They're concerned about it. We need to be concerned about it, not only because the public is, but because it's the right thing to do for us to be good stewards with respect to the environment. As a result of that, there are several things that we as an industry, whether it's the airlines or the OEMs, have committed to do to assure that we will be good stewards of the environment and that we can achieve the growth in our industry that we're talking about. The first thing is that we've committed as an industry to see steady improvement in the efficiency of the global fleet by assuring that the fuel efficiency and the CO2 output of the fleet is reduced by 1.5% a year. We're also committed to what's called carbon neutral growth by 2020, so that going from a 2005 baseline, that even though the number of airplanes is going up dramatically, that the amount of CO2 put out into the atmosphere will be flat from 2020 on, even though the number of airplanes is growing. And then the most aggressive target that we as an industry have agreed to is to attempt to achieve a reduction, an absolute reduction in the amount of CO2 that's put out by 2050 by 50% from the 2005 baseline. So these are very aggressive targets that we as an industry have taken on and we expect to achieve. So what's the plan for achieving these things? This chart shows a forecast of emissions growth if you didn't do anything. That's how they would grow. It's just sort of give you a general notional sense of the directions. So there are a few things we're going to do to achieve the goals from the previous page. The first is create more efficient airplanes. That takes you down from the very top of the curve down one notch there. The second area there is more efficient flight, improving the ATM system and how we use the airplanes. And then the third part that's going to get us the biggest contribution is to have more sustainable fuels. So starting out with, let's talk about fuel for a second. I think Derek mentioned the oil shock and how fuel went to $140. Oil went to $140 a barrel. And by the way, if there's ever a discrepancy between anything I say and anything he says, he's right. He's the customer. So let's just get that taken care of right now. The other guys I'll argue with. I'm not arguing with Derek. Eric might argue with me on the environment stuff, and he knows what he's talking about on that front as well. But on the front of the more efficient airplanes, there's a very nice synergy between the amount of CO2 you produce and the amount of fuel you burn. Because the fuel is one of the largest costs for an airline, you have to average it out, maybe 40% of their operating cost. You sort of get the environmental improvement at the same time you get a help to their bottom line. But fuel has doubled as a percent of airlines' cost over the last 10 years. A lot of the growth that you see in the planes that we're making and selling is because the airlines, to be profitable, have to deal with these increasing fuel costs. They need more efficient airplanes. For single-aisle airplanes, fuel has gone in 2003 from 15% of the operating cost to something like 30%. And for wide-body airplanes, it's gone from 25% of the operating cost probably up to 50%. And so there's a tremendous push to have more fuel-efficient airplanes, and as a result, they put out less CO2. The way you achieve more fuel-efficient airplanes, so let's say for every 10% of improved fuel efficiency and reduction in CO2, this is where it comes from. Probably 40% comes from improved engine technology. Mike can talk about his long career at GE and how they achieve that. And then the other 60% have broken down fairly equally between aerodynamic improvements, such as reduced drag, et cetera, improved materials like on the 787 using composites as opposed to aluminum to reduce the weight, and then systems improvements, a more electric airplane, for instance. I would point out that all of those factors, of systems, materials, and aerodynamics also are the main contributors to how the engines get their improvements. And so we constantly are investing, doing R&D in everything on this circle because it pays off doubly for us. It reduces fuel cost, and it also reduces our environmental impact. If you look at it that way, in commercial airplane R&D, we can say, look at our portfolio, what we invest in, and 75% of what we invest in reduces our environmental footprint. We've got a long track record. Abe shared some of the history that to maybe some of the people in the audience looks like it was progress made over a long time. I think that was a very short time. As I get older, the unit I use to measure time is my age. And so when I see 30 years of, progress, what happened in 30 years, that's a very quick time, especially for the complexity of the projects we're working on. Since the early 60s or late 50s, we've seen tremendous improvements. We produce 70% less CO2. We use 70% less fuel. The noise footprint has been reduced by 90%. The 787, for instance, was the first of the airplanes that we produced under an internal commitment we made that every new airplane we make will be at least 15% more fuel efficient than the airplane it replaced. The 787 turned out to be closer to 20%. When we came out with the 747-8, that was 16% more fuel efficient, less CO2 producing. So our industry has a track record of taking on these challenges and succeeding. The next area is the more efficient flight. 3 billion people, I believe, flew around the world in 2014, and that's expected to grow to something like potentially 7 billion by 2033. But given all the great advances we've seen in the airplanes, the air traffic management system is still based on a 1950s paradigm where you have ground radars, ground controllers telling a pilot where to fly based on the assumption that the airplane doesn't know where it is, can't navigate itself, doesn't know how to manage separation distances between other airplanes, doesn't take advantage of any en route, a lot of the capabilities that are on the plane. We believe, and many people believe, that through improvements in the air traffic management system, you can reduce the fuel use by another 12 to 15% and double the capacity of the airspace just by taking advantage of satellite communication, allowing pilots to fly the most efficient route based on winds, weather, optimizing separation distance, using continuous descent approaches, et cetera. So there's tremendous opportunity for us with the air traffic management system. The next gen system in the United States, CSAR in the EU, both give us the opportunity to take the air traffic management system to levels that will provide these savings. The third area I want to talk about has to do with sustainable fuels. To really get down the amount of CO2 that you put out, you have to absorb CO2 while you're creating the feedstock for the fuel, and that's what biofuels do. Sustainable biofuels are biofuels where while you're creating the feedstock, you're absorbing CO2, but you're not using water, drinkable water, and you're not using land that could be used for food, and you're not using feedstocks that could be food. That's the key about sustainable biofuels. Boeing is never going to make biofuels, but we see our role as central to the industry to encourage and catalyze the industry to come up with the sustainable fuels that are affordable, price competitive. In 2011, the industry gained approval to fly the first commercial flights with a 50-50 blend of petroleum-based and biofuels. And since then, airlines have flown more than 1,500 revenue flights using biofuels. We actually believe that by the year 2016, 1% of all jet fuel can be provided from biosources, and that's something like 600 million gallons a year. We believe it can be cost competitive by 2020. There's a certain tipping point when you get to about 1% that we think will really supercharge the industry. One of the things that we do on all of these technologies is we have something called the Eco Demonstrator Program, where each year we take an airplane and we put various technologies on it that have an environmental impact, and we test them out. The first one was the Eco Demonstrator with the 737. We did that in partnership with American Airlines, where we flew one of American planes around with all these added technologies on. And this allows us to shorten the cycle time. Abe talked about the time from a program start to when it actually enters into service. And this is one of the techniques, we agree with them completely that has to be radically reduced. The Eco-Demonstrator program is a way that is one of the techniques we're using to try and dramatically reduce the time it takes to incorporate new technologies safely and efficiently. The 787 Eco-Demonstrators flying right now, many different technologies were tested. One of the key ones there was we had a ceramic matrix composite nozzle and center cone on a Rolls-Royce engine, and we tested that. Provides significant advantages for us as exhaust gas temperatures goes up. Maintainability of these nozzles is excellent. Weight reduction, maintenance reduction, et cetera. And the 757 Eco-Demonstrator, which will fly next year, the big project on that is going to be done cooperatively with NASA, active flow control on the vertical tail. So this is one of the techniques that we're trying to use to shorten the development cycle time for environmental projects and for all technologies for that matter. My last chart is, we think this industry is a benefit to the world. It connects people in ways that could never be done. People that couldn't afford flying before can now fly. It's an engine for the world's gross domestic product. But for us to achieve the growth that we see, the potential for our industry to grow and for the world to benefit from the commerce it creates, we have got to be good environmental stewards. And so taking on the problems that I mentioned is something that I think is essential for us to see that vision. Thank you very much.
Thank you, John. Well, we really had the benefit of listening to three speakers with three different messages, of free messages of different kinds, which are not necessarily at odds, but very interesting. Obviously, the view of the industry, and I think what is interesting listening to Derek is really how streamlined is becoming. With really three major carriers driving, maybe four, but three major carriers driving the industry in the U.S. and giving a chance to the airlines to become profitable. Let's face it, they're the customer, as we keep on saying. We're not profitable, we don't have a business. Abe talked about innovation, and innovation is very exciting, and he went through a lot of different things that have been innovating over the last few years. Talked about the time to develop products and how they can be shortened. And I was happy to see how he showed what we all have done on the commercial side of the house. Still a lot of work to be done on the military side of the house. And then John talked about really all the things that Boeing sees ahead, and these are really exciting things altogether. So we have, well, we say probably have 15 to 20 minutes to open this to questions for our panelists. So please go ahead. And how are you?
Yeah, I'll be happy to take that. It is true that commercial air transportation is 2%. It's growing to 3%, could go to 5%. We believe that it's our responsibility to work on the contribution that we're responsible for. Clearly, other sectors need to be working on theirs, ground transportation, et cetera. So I don't say they shouldn't work on their part, but I feel responsible for working on mine. The biofuels, for instance, we believe that with biofuels you can reduce the net CO2 from the entire cycle, not just flying the plane, but growing the feedstock. It's debatable. Some people say 60 to 70%. And since, for the other parts of the discussion, more efficient use of airplanes, ATM, et cetera, there's a direct economic benefit to the airlines of using less fuel. It's just a synergistic benefit to do all three of these things together. I couldn't sleep at night if we weren't trying to reduce our environmental footprint.
I would like to say, I'm not trying to get John off the hook, but basically,
Please
the
do.
nature of flying in the atmosphere means that it's easier to try to reduce CO2 on things that ground bound or surface on water or whatever than in the air. So pushing as hard as he can, fine, but guys, it's not as easy to fly at 0.85 Mach number at 37,000 feet as being on the ground. So push some other things more. That's what I'm trying to say. And this is just physics.
Yeah, one of the things that we're concerned about is that a lot of the sustainable biofuels could be used by ground transportation. They should be used by ground transportation, and that would minimize the amount left for commercial airplanes. So we're hoping that those kind of trades aren't made and there's enough for everyone. Everybody can improve their footprint, all sectors.
If I could add one thing about this, talk about reducing basically pollution coming out of engine aircraft, and John alluded to that. There's a whole world that had to do with operation of aircraft, which is really the next gen, going to satellite-based navigation and so on, but has a number. This is a number of, let's call it 12 to 15%, and it's there to be taken. And we really need an effort, a really driving effort from the FAA and others to take us there, because the technology is available. It's just a question of execution. Any other question?
Yeah, this is for John and maybe for Derek. If you take a look at what happened in the 1950s, when we went from the DC-7 and the Super Connie to the 707, it really changed the business cycle. You could do an East Coast to West Coast trip and vice versa in one day, have a meeting, et cetera. If I look at an airplane today, they look a lot cooler, they're far more efficient, they still fly at point Mach 8.2, or maybe a little bit faster in the old days because we could burn more gas. And the new airplanes won't change the business cycle. If we want to change the business cycle, for example, to Asia, we need to go 1.6 or 1.8. And so from the airline and from the manufacturer perspective, if we can solve the sonic boom problem, what do you see for the future of flight that can change the business cycle by going twice as fast as we go today?
Okay, you start or want me to? You start. Okay, thanks, Al. We believe that technically, as you know, the supersonic problem is solvable. We could create a supersonic commercial transport today. The problem is the cost of the tickets would be significant. We had, Ed Petkus is here, one of our key designers, a Michigan grad. He was involved in something called the National Parks Program, where there was Glacier, Yellowstone, there was another one, and this is where the 787 came from. We had the Sonic Cruiser was one, and then there was a supersonic airplane, and then there was the 7E7, which became the 787. We could have developed any of those, and some of them would have directly addressed the concern you had. Before that, we had the HSR, High Speed Research Program, High Speed Civil Transport, NASA, Boeing, McDonnell Douglas, et cetera. So we have the technology, but in the end, the customers don't want to pay. As you get closer to Mach 1, the drag goes up, the fuel goes up, and the costs go up. The customers don't want to pay. And so our decision on which airplane to develop is dramatically impacted by the airplanes that Derek wants to buy.
Yeah, no, I totally agree. I mean, the decision we make for when we want to buy or what type of aircraft we want to buy, all of that goes into the equation, right? And even the aircraft that we're replacing today, there's always a decision on whether you keep the old plane or buy the new plane, and how much more efficient is the aircraft that you're going to get as you move forward. Because you can keep an older plane will stay in the air. It's just what is the cost of maintaining that older plane and the fuel burn efficiency of that older plane versus a new plane, and that's always offset by the ownership costs, right? And I think in the case that we're talking about, the ownership costs would get to a point where you couldn't put enough seats on that aircraft to make the aircraft profitable, and is it going to make that much difference if you cut that flight by an hour? Is that passenger not going to fly you or not pay because the flight is an hour less or an hour longer? So I think there's tremendous, the 787 has a lot longer legs and is a great product. The A350 is now going to come on with longer legs and a better product. So there are product efficiencies that are making things better. So that's where we're heading right now. But it all comes down to, cost, and then it's the demand of how many aircraft can they sell and how many people want those aircraft to go forward.
Yeah, Al, you mentioned the passengers saving time. Our take at that was by letting them go from the city they live in to the city they wanted to go to and not having to go through hubs. And they save many hours that way, and they're saving money because of the fuel efficient use. You would have an incremental addition of time savings by flying faster, but the cost would go up, and we're just not seeing that people want it. Yeah. We still don't see people wanting to pay for it.
Honestly,
Cost of seat mile, give me a second. A cost of seat mile being key, I can see supersonic happening at the executive jet level because people who have more may pay more for speed. The other thing that can be reducing the home to business, business to home, door to door, is in the ranges up to 100 mile is VTOL transportation. That's what I was talking about. That's the only thing that I think people will pay for if the seat mile is the same and safety is the same.
I have a Wall Street type of question. Warren Buffett talks about moats all the time. Schlumberger, for example, has a moat in technology, Oracle in terms of installations, Apple in terms of technology. What do you see, Mr. Kerr, will be the moats in the industry that will allow you to be successful? I mean, you could be humorous in the old days. You could say, well, all you had to do was go out and lease a plane, and you can have a
From an
creative-
innovation perspective, how will we be successful?
In terms of moats, I mean, will you be able to have distinctive competence amongst American Airlines and the three principal suppliers you're speaking about? And the other, which is a vastly different question, how do we stop the Air Malaysia can't find the airplane problem as we go forward in the future?
No, I think I'll just start number two. I mean, is just technology in the cockpit, right, or information to, I'm sure we will have to all go and make sure that there is, a system where they can be tracked, and a system where we can make sure that we know where that aircraft is at all times. And no one, I mean, maybe John, more than I do, but no one has any idea what happened there. And where it went. There's all speculation on what happened. For the industry, from a investor or a Wall Street perspective, the real reason that we have been successful is capacity discipline. The industry over time had been more market share driven and had been how do I drive market share and how do I get as much market share as I can, not worrying about profits. The people running airlines were operations people. They weren't finance people. So now the leaders of each of the airlines are either legal people, actually, or finance people that are running the airlines, and it's all how do we become profitable and how do we have an industry that's investable and how do we make money versus how do we drive market share. So it's a totally different environment out there. We all know that you can't just grow capacity without, as we talked about capacity versus GDP. It's fine to grow capacity, but you can't grow capacity more than GDP or your revenues are going to decline. So I think it's the discipline that we've had from a domestic standpoint to retrench back to our hubs, to our strengths, and get out of unprofitable flying and retrench it back to what's profitable and not grow where you don't need to grow. So I think that's where the industry have gone over the last 5 years. And I think from a management perspective, they're all talking about making profits and sustained profits versus market share, which has been a huge change in the industry over the last 10 years.
On the MH370 question, IATA and ICAO both have had several meetings, and I think by February of 2015, they will have agreed on an international standard on how we're going to do flight tracking. But there's two parts. There's knowledge of where an airplane is at every moment in time, and then there's also the second problem of, do you download all the data in real time for all those airplanes in the sky? The tracking one is more easy to handle, and that'll be tackled first and implemented very shortly.
I think we have time for one more question. Go ahead. Go ahead.
In the
The question is
meantime, a
here.
comment here.
Kimberly?
You were talking about market share.
Yep.
A market share doesn't have to be, in your perspective, if you can have a better solution for the shorter range, you're going to eat into high-speed trains.
Correct.
He was going to
Thank you. Is it on? In the early 90s, Boeing developed an aircraft with advanced materials, it was a digital design, lots of new technology called the 777, and it was delivered on time, on budget to United Airlines, I think, as I recall, in 1995. Since then, we've had exponential increase in computing power, new tools, 3D AERO, CFD, et cetera, and it now takes 7 to 8 years to develop a new commercial aircraft. And the costs, with the overruns, the Boeing CEO has now said, famous quote, no more moonshots right now. We're going to go incremental rather than more aggressive. My question is, what happened with all this technology available to us? Why is the cost to develop, or the time to develop a civil airliner doubled?
Yeah. I guess that one's for me.
we'll
I'm just assuming. Abe's probably got a good answer.
I may help you with that.
Derek wanted me to ask that question.
Thank you. Thanks, Kevin.
I don't believe that clearly with the 787, the time it took was the time it took, so I can't debate that. But I'm not going to say that the time it takes to develop a new airplane is now 7 years. We are one of our biggest focus areas is cutting that time down. On the 787, this moonshot comment was meant to talk about how on the 787 program, we layered new systems, engineering systems, supply chain management systems, a new business model, new materials. Everything was put together all at once as opposed to incrementally bringing out these technologies. I mentioned the eco demonstrator, for instance. That's an approach to assure that we don't take 7 years again by regularly and systematically fielding new technologies and making sure they're at NASA technology readiness level 9 before you launch a program. So we have something called the Development Program Excellence Initiative, where we're looking at the best practices from every program we've ever done and some of the escapes from every program we've ever done to assure that we can dramatically break the Norm Augustine curve. You had the Augustine curve. We think that we can break that cost curve, the dramatic cost growth, and the cycle time to develop a new product by maybe as much as 30%.
John, let me help you a little bit.
Thank you.
So I hope
Abe is always helpful.
787, I hope, is an anomaly. Somebody, maybe under pressure, I'm looking from the outside, I don't know the facts. Pressure from Wall Street or whatever, don't take risk, don't put $14 billion of Boeing money and bank money. And they took a pie, sliced it in 6, gave 3 pieces to Japan, gave 1 piece to Italy and 2 pieces to the East Coast, and they had to teach 6 companies to build what Boeing knew. Now, that was a mistake. They are walking out of it. I'm looking from the outside. But don't say that because of that, we are growing like the military from 5 to 7 to 8. I don't think it's also tied to the technology. I think it's all business model.
I do believe it was mainly business model related. But the fact is, the airplane saves 20% on fuel. There's probably 170 of them out there flying today. And in the short time they've been flying, there's 1 billion pounds less fuel burned just because of that one plane. Fastest selling wide body in history, I believe, before launch. So the program was a tremendous success. The pain it took us to get there is something that we don't want to repeat. We publicly say that we were too aggressive with the horizontal integration that we did, and we need to be more selectively vertically integrated in certain places. But the fundamental business model of having partners, I hate to disagree with you, we're going to keep the strong partnerships with suppliers, but we're going to redraw the lines a little bit and make sure that we have greater participation with the work that the suppliers do. So we're quite confident we can break this development cycle time curve and get the costs reduced, because it's not sustainable if we stay on that path.
But we still need a very strong technical leadership of a program, or otherwise it's not going to happen.
You will not be successful without innovation, technology, and strong program management. You need them all.
I think that's a great discussion. I'd like to throw in my ideas about jet engine development, but I'm not going to do that in the interest of time. I really want to thank the panelists for doing such a great job in getting everybody's attention. I really appreciate the audience participation. I think it was a great morning, and thank you very much for everybody.